Okay, so we're starting today, kind of weird, but I'm starting today with talking about some of last night's homework. And I was just talking to kids, it is September the 10th. But we were just talking about that some of these are what I'm going to call doable, even though it's not a word, and some are way harder. So I want to start with the ones that I feel like a 6th grader should be able to do. We're going to jump around a little bit. Here we go. So let's say I'm staring at this one. Okay, can y'all see that one? Okay, 7/21. So all you're doing when you simplify, you should be thinking what goes into 7 and what goes into 21. 7, right. So this one isn't that bad because we know our 7s tables. We're going to divide the top and the bottom by the same number, and we're going to get 1/3. So like that, we should be able to do. Another one we should be able to do is honestly the one right below it, number 9. Because it divides by 7 again. Okay, so 3/8. That says to me, like if you can do those, that you know your 7s tables. Okay? Now, I can even look at number 8. Number 8 should be divisible by what?
20.
20 is the biggest. Someone could do 5 or 10. It's just 20 is the fastest. It is the greatest common factor. And remember, when simplifying, you're doing top and the bottom by the same number. 1/6. Another one that I feel a 6th grader should be able to do pretty easy is like that one. 11/44. Divisible by 11. And it's 1/4. Now, I'm going to say this. I'm going to kind of throw this in, even though it's going to be part of your definition later. Simplifying. There's another word for it called reducing. I don't love the word because you guys think that that fraction is officially smaller than that fraction. But I want to show you something, and this is just a goofy picture that I drew earlier. But if you look at these, whatever, you can call them pizzas, pies, whatever, I don't know. I need you to understand that, and y'all get it, that this is a half. That's 1/2. Everybody agree with that? Okay, if I take the same exact circle, pretending it's exactly the same, and I do that, how many are shaded in? 2/4. Okay, pretending it's the same exact circle again, I have 4/8. The simplest form is that. The reduced, the simplest. But does the amount really change? No. It's just that this one is cut up in what I'm going to call simpler numbers. Now, the reason I say that is, if you think about it when you start in kindergarten, we start with numbers like 1, 2, 3, and 4. Well, honestly, these are just easier numbers to work with than as you get bigger. Or even, if we go back to this one, it's easier to work with a 1 and a 4 than it is an 11 and a 44. So reducing is not like shrinking, like we think of reducing as making stuff smaller. It is literally just numbers getting smaller. Okay? So I want to kind of throw that out there. I know it's weird, I'm jumping around. But, okay, so let me show you another one. Let's say we have this one, number 11. Whoops, my finger's not the right spot. Okay. What is the trick on 11? Divide by 2. How do you know to divide by 2? They're even. Anything that ends in an even number, the last digit to the right is even. Even numbers, 0, 2, 4, 6, and 8. That means if nothing else, you can divide by 2. Now, I'll admit, sometimes you can divide by bigger numbers, but if you don't know, you can just do that. This one, if I divide by 2, I would get 23 and 74. Now I would want to make sure it doesn't simplify again, but it doesn't. So that's another trick. What if it ends in a 5 and a 0? So let's say it's something like this. It ends in a 0 or a 5. It's always dividing by 5. Once you think about it, skip count by 5s. 5, 10, 15, 20. They all those numbers end in a 5 or a 0. That means you can simplify by 5. It's just another trick. Okay? The last one, put it up. Put the water bottle in your book bag. No, your book bag. The last one is ones that might be what I'm going to call super hard. Okay? Ones you don't know off the top of your head. You won't have many of these, but we have to kind of be ready for when we do have one. So let's say we're on 13 here. And I know this one was more rough, and in fact, I think this is the one I messed up. But if I take 13, and I have this fraction, and I don't know what goes into it. I don't see what I'm going to call, give me a second. Okay. Oh, I know what's wrong. Y'all should have told me it was not focusing right. Give it a second. It's having a moment here. Well, it has to do this autofocus thing, and it's not loving me right now. 1 second. Okay, it is recording. Okay, so we have this big number. I had no clue what equals 117. I'm looking for some tricks, like, do they end in even numbers? No, 7's not even. Does it end in a 5 and a 0? No, because it's like ending in a 7 and a 6. What I'm going to have to do is think about the multiplication tables that go into these numbers. And in my brain, I can do this. But if you can't do it in your brain, you got to kind of think, you may have to think it out on paper like this. So, I'm going to take the two numbers, and I'm going to start thinking, well, I know this is 1 times 117, and this is 1 times 126. Now, I'll admit, I know 2 works over here, but does it work over there? No. So, I'm going to try 3. Okay, 3 times, and this is where if you don't know this part, can y'all see this? Can y'all see me doing this? Okay, so, yeah, what I'm wanting you to see is the extra division. So, if you don't know how many times it goes in, you may have to sit and figure it out. Okay? Now, on this one, so 3 worked here. I'm going to see if 3 works here. Be 4 and then 2, 42. Yep. So this is 3 times 42. So what you figured out, yes, it took some division, but what you figured out is it's divisible by 3. Now, okay, I take that. I'm going to kind of block that off now. Okay, and I got 39 over 42. Now, I'm going to kind of have to go down here. Okay, now, that does not mean that you're always in the simplest form. You got to ask yourself, well, does it end in even numbers? Does it have a 0 and 5? You got to make sure. I know that 39 screams at me 3s. If you think about it, how many 3s are in that 3? 1. How many 3s are in 9? Listen, how many 3s are in 9? 3, okay. How many 3s are in 4?
1.
And then if I had 1 left over to make a 12, 3 into 12.
1.
3 into 12. 4. I just simplified this thing by 3 again. All it means is that at the top of it, I could have done it times like divided by 9. I just didn't realize it because I jumped on 3 first, and it wasn't like the GCF or whatever. Listen, you got to get it to its simplest form. I just didn't read when I read my paper yesterday, I was like, oh, divide by 3. Well, I didn't realize I had divided by 3 twice, which is fine. As long as you get to that answer, you're right. I'm going to be honest, and I know I'm videoing, and I'm going to say it. Multiplication tables are the key here. If you don't know multiplication tables, or if you know there's a certain number that you need to work on, you want to study them, because it's going to really affect fractions. Big time. 0 through 12. Okay? Big time. It just makes this so much easier. Okay? So with that being said, I'm going to put up here the answers. If you did finish it last night, let you just kind of see it. If I can find it. What I sent out last night was what each one should be divided by. Some of them I didn't want to send you, but then I ended up sending them anyway. So, well, it just made it too easy. Oh, I forgot about this one. Let me shrink it one sec. Okay. One that I forgot to ask you about was this one. Learn about simplifying that. 83 over 83, is one whole. And think about it. One whole is the simplest number that we can have. Yes, 1 once, but still 1 once can be made a 1, which is even easier to understand. Okay. And that 13, I think it is there in the middle, that's one I told you that I had to do twice to get the 13 fourth. Division. This is why we taught you division before now. Because it is everything we're doing, a lot of fraction stuff, it is division. A lot. I don't know how to explain it. Okay, so if you are done with that homework, I'm going to give you today's notes, and we're going to finish it. You're good. You're good. Listen, I'm not stressed over this. If you'll just put this back in your binder, I'm good with it. Here is the deal with simplifying. The more you do it, the easier it gets. I should be able to okay. Now I'm going to do something kind of silly and show y'all. Remind me to give you a pass. Okay. This is something I did with my last class. And to practice simplifying, I want you just to kind of look for a second. I should be able to take any two numbers, I want you to think about this, and ask you what they have in common. 1 second, I'm coming. Okay, meaning what number, there's one, just keep passing it back. What number they have in common. Okay, just keep passing it back. Pass it back, pass it back. I just missed one somehow. Okay, so look up here real quick. This could almost be like a game, meaning, let's say I tell you this. Can y'all see it? Okay. What divides into both of those? 11. Bam. You should be able to simplify that. What if you had this? Oops. Both numbers. 9. 9 times 5, 9 times 11. 9s. Okay? Eight goes into that. Oh, 8. Yeah. Sorry. Divide by 8. Okay. Now, granted, 16 or something bigger might work, but 8's what I was kind of looking for. Let's say I have, even something like this. 10 or 5, but 10 will be a little bit easier. Listen, I should be able to, or your parents, ask you any two numbers that are within that multiplication table chart, and you be able to simplify like that. At least know what they divide by. Okay? So that's just a trick. Now, looking at that sheet, what we're going to do is we're going to keep practicing simplifying. But it's just like we're kind of thinking you know it. It's just we need more practice at it. So everything we're doing for the next forever, it seems like, is going to have simplifying. But what we're going to do is start with, whoops, 1 second. Okay, we make it a little bit bigger so y'all can see it in the back. A little bit bigger, I know. Okay, now get out of the way. Yes, so it is a whopping 3 definitions. Now, these 3 words, what we're going to do is we're going to start by changing decimals to fractions and fractions to decimals. In part of it, yes, we're going to be simplifying. When we make fractional answers, we will be simplifying. That's kind of why I needed to teach it before we can do anything else. Okay, so start now. When we have a numerator, we all know it's the top number of a fraction. It's above the line. It indicates how many parts of the whole amount we have. So if we say something like 1/2 or 1/2, we know that that means we have 1 out of 2. Like, we know that. Not hard. The second word there is denominator. We know denominators are below the line. A lot of kids will say down denominator for D and D. Like, the denominator is the one that's down below. Okay. Fractions are division. 1/2 means 1 divided by 2. That's why they put the little word divisor in there. Divisor, the word divisor, dividend, should be screaming at you, division. So we're going to talk about why fractions are division. Ow. And then that last definition there is simplify. It says to reduce a fraction to its lowest terms by canceling, I kind of wish it said dividing, but that's okay, to the lowest number in the numerator and denominator. But we actually know those. It's not getting smaller in the amount, like you're getting less pizza. It's just cut in different slices. So if you get 2 out of 4 slices, you're still getting half. You're still getting half the pizza. If the pizza is the same size, that's the question. Okay. Now, while you're kind of still copying this, I want to throw out there why we study fractions and decimals. I promise you, if I had my way, we would only have one of them. Because it's kind of like a couple different languages in math class. If you think about it. Decimals are one language. Decimals are money. I think of pharmacists and bankers using decimals. Think about, like, if you go pick up medicine from CVS and you pick it up and you get like 0.5 milliliters or 2.5 milliliters, and you're taking little bits and droppers and that kind of thing. Those pharmacists know how to work with decimals. Okay? Computer people, big time, decimals. Okay? Well, fractions are just like another language in math class. If you think about it, if you're a cook, a chef, what's on the back of the boxes in our pantry? Fractions, 1/2, 1/3, right? 1/4, cups. But it's all done in fractions, usually. So if you're going to be like a chef, you're going to have to know fractions. Probably like fractions. But listen, with decimals, to me, You got to know it for Money World if you're in the United States. Okay? But I want y'all to understand something. Like in 6th grade and through high school, we touch what is called like the basics of it all. Because we don't know what career you're going to go into. But I can promise you, like if you're going to be a pharmacist, somebody who mixes medications for us to get better, you're going to go way deep into the decimal world as you go off into college and things. Computer people that design all these computers and stuff, and I have no clue how to do all that. I promise, they're getting into the decimal world. And I promise, chefs out there, good chefs, people who cook for us, they're not always using a half of everything, okay? They know their fractional amounts. And they know how to mix it to make things taste right, so we eat it. So what I'm getting at is like, we do the basics of it all, so that as you go up, you can kind of figure out what you want to be and then use it up there. Yes?
What about if you're a teacher? You know,
Yes.
fractions, you know, that's what.
I'll be honest, just as a mom, a grown adult person, I got to know decimals for money. I'll be honest, I got to know decimals for what I call banking, percentages and mortgage rates and credit cards and things like buying a car, a house, those kind of things. Fractions and decimals, honestly, more decimals like with money, medicines and stuff with my kids. But fractions I see in a lot in baking and cooking and those kind of things. If you think about it. Trying to think, athletic sports do different fraction decimal type stuff.
Looks like if my mom every week, like she sees how much she has in the bank and how much that she spends like for that whole week.
Yeah. I mean, we all do that. If we're Money World, I mean, we are all constantly looking at the bank account and seeing how much money we have, how much do we have left. Now, granted, we all wish we had way more and we didn't have to look at it. Okay? Well, with fractions, y'all were saying, like, I think of football, and you go down half the field. Your coach is going to want you to, like, you got to know what that means. If he says run halfway down the field, if you stop at the 10-yard line, he's going to be like, what are you doing? Okay? So, like, there's a lot of this that you don't, like, if your coach says that to you, you don't want to be caught off guard and him go, do you not know your fractions? Like, that kind of thing. So, with all that being said, we're going to learn to make the two things talk now. Like, kind of be the same, okay? The one thing that's weird, and I always say this every year is, and I want you to kind of think about this. This is 1/2. Like, let's call it $half a dollar. How much is $half a dollar? 50 cents. That is $half a dollar. That is $half a dollar. I want you to think about it. All it is we talk this with money. If I walk up to you and say, do you have 75 cents? That you understand. Like, you know what I'm talking about. But most of the time, it's not 1/3, it's 3/4. 3/4 out of 4 quarters. So, it is the same thing, it's just two different languages. Okay, now, here we go. And if you will totally watch, this is not hard. Okay? Yes. Cool. Finish, because I'm about to move on. You couldn't eat it, but thanks. Okay, go ahead. 1 second. I'm just trying to. Okay. Now, yes. Sweet. This is where, okay, a lot of the curriculum or what I teach is repeated the first 9 weeks, like a lot of it. But about right now is where we start hitting the one teacher might have taught it and the next teacher didn't. And it just matters. A lot of it's just refreshing our brain with it so we can remember it. But then some of us need it full blown. Okay. So we're going to start with this, which is converting decimals to fractions. Now, a lot of you get home and you're kind of like you don't know what to do on the homework. Well, guys, we give you notes. We give you how to do it or whatever. But I'll be honest, you got to read it. You got to know you have notes. Today's notes, super important. Do you see these three numbers? 1, 2, 3. Kind of down the side there. Okay. All it is those are the 3 steps to change a decimal to a fraction. There's 3 steps. Kind of a 4th in a minute. Yes? Then throw it away. Throw it away. Finish with his definitions. He's trying to keep up here. Here, I'll try to remember. Right. Let's do this. Okay. You get that? Yeah. Oh, sweet. Okay, so converting decimals to fractions. Here we go. If you will, and you're going to have to memorize these steps. Okay. First, hint. I'm just trying to show you something. Do you see, guys, you don't have to highlight anything. I'm just trying to show you something. Do you see that these are decimals? And we're trying to change from a decimal to a fraction. Get it? Off your face. Now, number 1 says, number behind the decimal goes on top. So I want you to think about this. You are making a fraction. So think of a fraction bar. Whatever is behind the decimal is going to go on top. So on top I need a 98. Step 1. Whatever's behind the decimal goes on top. Step 2. The last place value goes on bottom. So what that means is wherever you are in the end, what column is that in?
8.
But what column?
Oh, hundreds.
Hundreds. That's right. So on the bottom, you are going to put 100. Now, if you'll notice something, I can read this as 0.98, or I could read it as the correct way to say it would be 98 hundredths, because that 8 is in the hundredths column. If you listen to how I said it or read it, that is how you should write it as a fraction. 98 hundredths. Here's another trick. If you're wanting tricks and you're wanting to catch the easy stuff or make it easier on you, look right here. How many numbers are on top? 2. How many zeros? 2. Yes. That is right. So listen, step 3. We're going to now simplify if we can. And yes, this one simplifies by 2. So this would be 49 and this would be 50. Does anything simplify 49 50ths? Nah. Because this is 7 times 7, but 7 can't go into that. But listen, if you divide it by 1, what would you get? 49 50ths. So you don't simplify by 1, but any other number. Okay. So you got it. Like that is the fraction that equals that. We just normally say 98 cents. We don't walk up to someone and say, do you have 49 50ths of a dollar? Yes.
If you can't go anywhere and the only thing you can do is divide it by 1, then you know that
That's right. That's right. Uh-huh.
What would you, so do you just, like, ignore the number before the decimal?
No. Y'all are, listen, let me get to it. I promise I'll explain it. Okay, I just find it interesting because some people haven't written down number 1. So, okay, on number 2 here. Couple things. Okay, if you read it, it's 15 and 715 thousandths. Now, that front number, if there is anything in front of the decimal, it's kind of like a fraction that has the big number in front. It's going to be a mixed number. It's got the big fat number in front. But luckily, you don't have to do any math with it. You just copy it. Okay? Now, on the back side of this, you've got 715. So looking at our steps over here, 715 goes on the top. What goes on the bottom? Guys, what column is that 5 in? Thousandths. I want you to look again. There are 3 numbers up top. How many zeros? 3. Plus the 5 is in the thousandths column. Now, we got to simplify. Okay, 15 stays the big fat 15. If I divide by 5, top and bottom, keep the big fat 15 because it stays the same. Now, 715, 5 will go into it once. There'll be 21, which is 4. 15, which would be 3. 5 into the bottom would be 200. And you have now put it in simplest form. Okay? These steps for changing the decimal to the fraction are the same. It doesn't matter which one you're doing. They are the same. Doesn't matter if it's got the whole number in front or not. Just take whatever's behind it, put it on top. Yes?
So if you're converting a decimal into a fraction, it's either going to be like a 10,
On the bottom? Yes. 10, 100,000, 10,000, yes. Yes. That's where the simplifying is going to come in. You'll start, the more you simplify those normal numbers, like 100 and 1,000, it'll get easier. It'll get easier. Now, on the bottom part, now we're going to convert a fraction to a decimal. Now, starting out thinking, a fraction has the bar. A decimal has a dot, whatever you want to call it. Okay, the one last trick that we gotta know is that fractions mean division. It is top divided by bottom. I want you to think about this. I've even got the word divide. You need to stop, is all I'm going to say. Don't even pay attention to them. Stick with me. With this, we're going to have to do division. That's why we taught division for the last few weeks. Look at it. It says it right here. So, when staring at a fraction, it says the numerator is going to go on the inside of the house. The denominator is going to go at the door or on the outside. Okay, so they just told you how to do it. You just got to kind of look at it. Okay, 8/18. So, if I kind of do the little house thing, or whatever you want to call it. Okay. There we go. Okay. So, it said, put the numerator where? Inside. Inside. Like it says it right there. Numerator inside. So, whatever's on top, inside. 18 on the outside. Okay. Now, you're trying to build a decimal. That's why right here, we can't go in, 18 can't go into 8. So what we're going to do is we're going to add a decimal and a 0. But add the decimal before the 0. That way it's still $8 or whatever you want to call it. Okay. 18 into 80 is actually 4. I had to do the math real quick. Okay, 4 times 8 is 32. It ends up being 72. Keep going with my fancy math. Miss Donahue said that if I got a remainder, I got to add a 0. Ah, what's repeating? The 4, yes, because it's just going to keep giving me 8s and 72s, right? So, here is what you've done. 8/18 is the same as saying 0.4 repeating. Or you could say 0.44 repeating. Or you could say 0.444 repeating. That is the decimal amount. You've got to have the repeater bar over the 4. Without it, it's wrong. Yes.
Why do we not have a remainder for decimal division, but for regular division we have a remainder?
It's kind of like the added feature of 6th grade. So to try to explain it, it's kind of like division starts out easy. And then as it gets harder and harder, you're learning about the repeating and terminating. Because some of them never end. So we just never really touch that. But yeah. Yes?
So, for me, the easy way to remember, probably easy for everyone, is if you have a bigger number on the outside than the inside, and you have to add a 0 to it,
Yes.
you make sure that you separate 0 from this.
Yes. Yes. So, and I get what you're saying. Okay. So like this one. And I'm going to get to that in 1 second. Okay. Start with that 5. We know that if it's a 5 as a fraction or a 5 as a decimal, it's what I call the big fat 5 in the front. And then add the decimal. That is the same as that. That way we don't have to do anything to it. I don't really have to do any math to it, okay? Now I'm going to work with this, which is what you were talking about. 16 goes in the house, and 20 is outside the house. So yes, if this divisor is bigger than the dividend, and you know 20 won't go into 16, you're right. We're going to have to add a decimal and a 0. So how many 20s are in 160?
3.
Count by 20s.
8.
8. 8 times 2 is 16, right? Okay. So I want you to think about it. You got it? Like it's done. So our real answer is 5.8. Yes, or 5 8/10, whatever you want to call it. It's really not hard. It's going to be harder on if we don't know our division skills, just to be honest. Okay, number 3. So looking at the front number, I'm wanting a decimal, so I know that I'm just going to write that thing, 7 point. Okay, I'm going to take 4 over 45. I'm going to divide 4 divided by 45. Kind of weird. Okay. Can 45 go into 4?
No.
No. Got to add a decimal before I can add any zeros. Can 45 go into 40? No. So I'm going to add another 0. Can 45 go into 400?
Yes.
How many times? I'm going to be honest, it's 8. It's okay. Okay. And it ends up being 360. And I get 40. So what if I bring down another 0? It's repeating. What now listen, slow down. What number repeats? Just the 8, right? Because the next thing would be another 8, and another 8, and another 8. So, when you write this, we can't ignore that 0. That's part of the answer. So, over here, it's going to be 7.08 repeating. Please be very careful that you put all of that with the 8 repeating. I find this interesting. This is 5th period's notes. So I've done all this in front of students today, and some of them I haven't seen the pencil move at all. I'm hoping we get with me now. Yes. You can, yes. And then put the bar over both the 8s. Yes. Okay, so let's look at the back. The back is the official homework, but we're going to do some of it in class. Most classes I've done the first 2 of each section, leaving them with 8 problems. They've had time to kind of work on a few more. So, okay. Now, once again, you've got notes on the front. So if you need them, look at them. Okay. We're going to take this decimal. We're going to make it a fraction or a mixed number. Okay. Then we're going to simplify. Here we go. So think about it. Whatever's behind the decimal is written on top. What is on the bottom?
0.
How many zeros? 2 with a 1, because the 5 is in the hundredths column. And then what simplifies it?
5.
5.
Yeah, 5. Because it ends with a 0 and it ends with a 5.
That's right. Because of that, it's divisible by 5. That's right. 7/20. You got it. Okay, so look at number 2. Big 12 in the front, right?
Yeah.
And then 9 over 10. 1 and 1 0, right? Because 9 only has one number, so 0 down the bottom. 1 0. It's kind of a trick. I hate to teach it to you, but it works. Okay. Can 9/10 simplify?
Yes.
No, 3 and 9, 2 and 5, 10, but no, nothing goes into both of them. Okay. Let's go down to 7. Let's see if we can remember how to do this. And guys, you got to get these steps memorized. Uh-huh.
So, you put the 12 beside it. That's like how many holes you have?
Uh-huh.
Okay.
Number 7, 6 and 1/5. Okay, so if I want to make a decimal, I'm thinking, oh yeah, it is the big 6 in front, and the 1/5 is what I got to kind of figure out. Divide. So 1 divided by 5. That's right. So add a decimal and a 0. How many 5s are in 10? 2. You got it. So add that up here and you get 6.2. 6.2. 6 comes from the front number, and 0.2 is coming from the fraction.
So you just add the last year times the 6 and 5.
You can. You could do and change this to 31/5. You can do that, but it's kind of, to me, more work. Yeah, but if you like, because like on this one, look how big that number would be. 6 times 94 plus 4 divided by 6. You can do that. It's just more work. So what I do is I say, like, take the 94, write it as just a big fat 94, and then just work with the division of 4 divided by 6. Okay? Yes. Can 6 go into 4? No. 40 is 6.
36. Which makes you up by 4. So 90.
Repeating. You got it. So 94.6 repeating, or 0.66 repeating, whatever you need. Yes.
So
don't have the directions down here, so you didn't copy all my notes, is the problem. The directions are right here, guys. But if you don't take the notes, you have nothing to look at. Same thing. You have nothing to look at. I'm not trying to be mean, but I'm trying to, like, some of you've got to kind of jump into math. I know it's fifth period, it's after lunch, all that good stuff. But I hope tonight, I mean, if you need help, like, watch the video. But some of you won't take my notes, and I'm trying to help you. I'm trying to make you know, have a good grade. One example, like, that's why I don't do one example, guys. If I did one example and let you loose on something, you would, like, you'd be lost. So I do 2, 3, 4, 5 examples of stuff. You won't write it down, you have nothing to look at. Yes?
Number 2. The way that you, after you did it, like, oh, I didn't know that you did number 2.
Huh?
Because I was doing it on my
You just can't simplify it. So, most kids who've left out have had 3, 4, 5, and 6. And then I did in most classes 7 and 8. And then they had 9, 10, 11, and 12. Guys, I really need you to try this tonight. So we can work on it tomorrow and see what we need to learn.